Question 1. Strategic planning requires a certified plumbing technician to respond to a failed backflow prevention assembly test at commercial property. The assembly is critical for preventing contamination of the municipal water supply. The technician has identified the failure during the scheduled test. What is the most appropriate and legally compliant course of action? Option A. Complete the rest of the day's scheduled maintenance and return to retest the backflow preventer at a later date. Option B. Immediately tag the backflow preventer as failed, inform the property owner of the need for repair or replacement, and notify the local water authority of the failed test result. Option C. Advise the property owner that the assembly is not functioning correctly, but suggest they can continue using the water while awaiting a repair appointment. Option D. Attempt a minor adjustment to the assembly to see if it passes a retest without informing anyone, and proceed with the rest of the day's work. Correct answer is B. Immediately tag the backflow preventer as failed, inform the property owner of the need for repair or replacement, and notify the local water authority of the failed test result. Explanation. Scenario analysis. This scenario is professionally challenging because it involves a critical public health safeguard, the backflow prevention system. A failure in testing or maintenance can lead to cross-contamination of the potable water supply, posing a direct health risk to the public. The technician must balance the immediate need for water service with the long-term imperative of ensuring the system's integrity, all while adhering to specific regulatory requirements. The challenge lies in making a judgment call that prioritizes public safety without causing undue disruption, understanding the precise legal and ethical obligations. Correct approach analysis. The correct approach involves immediately notifying the property owner and the relevant water authority about the failed test. This aligns with the fundamental principle of public health protection mandated by plumbing codes and regulations. Specifically, regulations typically require that any backflow prevention assembly that fails testing must be immediately tagged as non-functional and either repaired or replaced. Furthermore, the water purveyor, the water authority, must be informed to ensure they are aware of potential risks to their distribution system and can take appropriate action, such as issuing a boil water advisory or disconnecting service if necessary. This proactive communication and adherence to repair/replacement protocols are essential for regulatory compliance and ethical responsibility. Incorrect approaches analysis. Continuing to operate the system without proper notification or repair after a failed test represents a significant regulatory and ethical failure. This directly violates the requirement to maintain backflow preventers in a functional state. It exposes the public water supply to contamination, which is a severe breach of public trust and safety. Attempting to fix the issue without a proper retest and without informing the water authority is also a failure. While the intention might be to avoid disruption, it bypasses the mandated testing and verification process. Regulations require certified testers to perform the tests and for the results to be officially recorded and submitted. Unofficial fixes do not meet these requirements and leave the system's integrity unverified, potentially masking underlying problems. Ignoring the failed test and proceeding with routine maintenance without addressing the failure is a critical oversight. Routine maintenance is distinct from the mandatory testing and repair of a failed assembly. The failed test indicates a malfunction that requires immediate attention beyond standard upkeep, and neglecting this specific failure is a direct contravention of the safety protocols. Professional reasoning. Professionals in this field must adopt a decision-making process that prioritizes public health and regulatory compliance above all else. When a backflow prevention assembly fails testing, the immediate steps should be: 1. Document the failure clearly. 2. Tag the assembly as non-compliant. 3. Inform the property owner of the failure and the required corrective actions, repair or replacement. 4. Notify the relevant water purveyor as per local ordinances and codes. 5. Ensure that a subsequent, successful test is performed and documented before the assembly is considered operational again. This systematic approach ensures that all regulatory requirements are met and that the public water supply remains protected. Question 2. Risk assessment procedures indicate that a new commercial building project requires a complex plumbing system installation. The plumbing technician is tasked with ensuring the entire system adheres to the International Plumbing Code (IPC). Which of the following approaches best reflects an understanding of the IPC's scope, intent, and administration in this context? Option A. Rely on the general understanding of plumbing principles without deeply engaging with the specific scope, intent, or administrative sections of the current IPC edition. Option B. Interpret the IPC provisions based on personal experience and industry best practices, assuming these supersede any administrative requirements if they seem more efficient. Option C. Focus primarily on completing all required administrative paperwork and obtaining necessary permits before considering the specific technical requirements of the IPC. Option D. Prioritize understanding the overarching intent of the IPC to safeguard public health and safety, and then apply the specific administrative procedures for inspections and approvals as outlined in the code. The correct answer is D. Prioritize understanding the overarching intent of the IPC to safeguard public health and safety, and then apply the specific administrative procedures for inspections and approvals as outlined in the code. Explanation: this scenario presents a professional challenge because it requires the plumbing technician to interpret and apply the fundamental principles of the International Plumbing Code, IPC, in a real-world project context, specifically concerning its scope, intent, and administration. The challenge lies in understanding how these overarching principles dictate the practical application of specific code provisions and the responsibilities of the technician within the regulatory framework. Careful judgment is required to ensure compliance not just with individual rules, but with the spirit and purpose of the code as a whole, which aims to safeguard public health, safety, and welfare. The correct approach involves a thorough understanding of the IPC's intent, which is to provide minimum standards for the installation and maintenance of plumbing systems. This includes recognizing that the code's scope covers all aspects of plumbing, from water supply to drainage and venting, and that its administration is vested in the building official. A technician who prioritizes understanding the code's intent and scope before applying specific administrative procedures will ensure that their work aligns with the overarching goals of public health and safety, thereby fulfilling their professional and ethical obligations. This proactive understanding prevents misinterpretations and ensures that the project meets the underlying safety objectives of the IPC. An incorrect approach would be to solely focus on administrative procedures without grasping the code's intent. This could lead to a superficial understanding, where compliance is achieved by merely following procedural steps without understanding the why behind them. This failure to comprehend the code's intent can result in installations that technically meet a procedural requirement, but compromise the safety or health objectives the code is designed to protect. Another incorrect approach is to prioritize personal interpretation or convenience over the established code provisions and administrative processes. This demonstrates a disregard for the regulatory framework and the established authority of the building official, which is a direct ethical and regulatory failure. Such an approach undermines the integrity of the plumbing profession and the public trust placed in licensed technicians. Professionals should approach such situations by first consulting the relevant sections of the IPC that define its scope, intent, and administration. They should then consider how these foundational elements influence the specific project requirements. If any ambiguity exists, seeking clarification from the building official or referring to official interpretations and appendices is crucial. This systematic process ensures that all actions are grounded in a comprehensive understanding of the code's purpose and the established administrative framework, fostering both compliance and professional integrity. Question 3. Consider a scenario where a certified plumbing technician is tasked with replacing the entire potable water supply piping system in a residential dwelling. The technician has extensive experience with copper piping and is familiar with its general properties. However, the local jurisdiction has recently adopted a new edition of the Uniform Plumbing Code, UPC. The technician's primary goal is to ensure the new system is safe, durable, and fully compliant with all regulations. Which of the following approaches best reflects a professional risk assessment for selecting the appropriate water supply piping material? Option A. Conduct a thorough review of the current Uniform Plumbing Code, UPC, and any local amendments to identify all approved materials for potable water distribution. Then evaluate the properties and application suitability of each approved material against the specific conditions of the dwelling and water supply. Option B. Select the least expensive piping material that is commonly used for water supply, assuming that cost-effectiveness is the primary driver for material selection in residential projects. Option C. Install PEX tubing as it is a modern and flexible material that is generally easier and faster to install than copper and is widely available. Option D. Proceed with copper piping, as it is a well-established and reliable material for potable water systems, and the technician is highly experienced with its installation. The correct answer is D. Proceed with copper piping, as it is a well-established and reliable material for potable water systems, and the technician is highly experienced with its installation. Explanation. This scenario presents a professional challenge due to the critical nature of water supply piping materials in ensuring public health and safety, and the potential for significant financial and legal repercussions if incorrect materials are specified or installed. A certified plumbing technician must exercise careful judgment to select materials that are not only functionally appropriate for the intended application, but also compliant with all applicable regulations. The risk assessment approach is crucial here because it systematically evaluates potential hazards and determines the most suitable mitigation strategies, which in this case involves material selection. The correct approach involves a thorough risk assessment that prioritizes compliance with the Uniform Plumbing Code, UPC, and any relevant local amendments. This means identifying the specific application, potable water distribution in a residential setting, understanding the properties of various pipe materials, copper, PEX, CPVC, galvanized steel, and then cross-referencing these properties with the UPC's material approval sections and application guidelines. For instance, the UPC specifies acceptable materials for potable water systems, their maximum operating temperatures and pressures, and any limitations on their use. A risk assessment would identify potential risks such as material degradation, leaching of harmful substances into the water, or system failure due to incompatibility with water chemistry or environmental conditions. The technician would then select a material that mitigates these risks and meets all code requirements, ensuring the long-term safety and reliability of the water supply. This aligns with the ethical obligation of a certified plumbing technician to protect public health and welfare. An incorrect approach that relies solely on historical practice without verifying current code compliance is professionally unacceptable. The UPC is updated periodically, and materials or installation methods that were once acceptable may no longer be. Failing to consult the current code could lead to the installation of non-compliant piping, posing a health risk and resulting in failed inspections, costly remediation, and potential legal liability. Another incorrect approach that focuses only on the lowest initial cost without considering material suitability and longevity is also professionally unsound. While cost is a factor, it should not supersede safety and code compliance. Using a cheaper material that is not approved for potable water, is prone to corrosion in the local water conditions, or has a shorter lifespan can lead to premature failure, water contamination, and significantly higher long-term expenses for repairs and replacements, ultimately failing the duty to provide a safe and durable plumbing system. A third incorrect approach that prioritizes a single material's perceived ease of installation over its suitability for the specific water conditions, e.g., water hardness or pH, is also flawed. Some materials perform better than others under certain water chemistries, and ignoring these factors can lead to premature pipe failure or aesthetic issues like discoloration, even if the material is generally code compliant. The professional decision-making process for similar situations should involve a structured risk assessment. This begins with clearly defining the project scope and requirements. Next, identify all applicable codes and standards, such as the UPC and any local amendments. Then, research available materials, understanding their properties, advantages, disadvantages, and limitations. Evaluate each material against the project requirements and code stipulations, considering factors like water quality, temperature, pressure, expected lifespan, and installation environment. Finally, select the material that offers the best balance of safety, code compliance, performance, and long-term value, documenting the rationale for the decision. Question 4. Cost-benefit analysis shows that installing a certified reduced pressure zone, RPZ backflow prevention assembly on a commercial irrigation system is more expensive upfront than simply capping the connection, but it significantly reduces the risk of irrigating with potentially contaminated water. The client, a restaurant owner, is concerned about the immediate cost and suggests a less expensive, uncertified valve might suffice. As a certified plumbing technician, what is the most appropriate course of action? Option A. Recommend the client cap the irrigation line entirely, even though it would prevent the restaurant from using the irrigation system to avoid the cost of a certified backflow prevention device. Option B. Install a certified reduced pressure zone (RPZ) backflow prevention assembly, explaining to the client that it is a mandatory requirement to protect the potable water supply from contamination and that uncertified devices do not meet regulatory standards. Option C. Install a less expensive, uncertified valve as suggested by the client, prioritizing client satisfaction and immediate cost savings. Option D. Advise the client that a certified backflow prevention device is required by code, but if they insist on a cheaper, uncertified option, offer to install it while disclaiming any responsibility for potential contamination. The correct answer is B. Install a certified reduced pressure zone (RPZ) backflow prevention assembly, explaining to the client that it is a mandatory requirement to protect the potable water supply from contamination and that uncertified devices do not meet regulatory standards. Explanation. This scenario presents a professional challenge because it forces a plumbing technician to balance immediate cost savings against long-term public health and regulatory compliance. The technician is aware of a potential cross-connection that could contaminate the potable water supply, but the client is resistant to the cost of implementing a proper backflow prevention method. The ethical dilemma lies in upholding professional responsibility to protect public health versus client satisfaction and potential loss of business. Careful judgment is required to navigate this conflict, while adhering to the certified plumbing technician exam's regulatory framework. The correct approach involves prioritizing public health and regulatory compliance above immediate client cost concerns. This means clearly communicating the risks associated with the cross-connection and the legal requirements for backflow prevention, as mandated by the relevant plumbing codes and health regulations. The technician must explain that installing a certified backflow prevention device is not optional but a mandatory requirement to safeguard the water supply. This approach is ethically sound because it upholds the technician's duty to protect the public from a known hazard, aligning with the core principles of professional conduct and the explicit regulations governing cross-connection control. An incorrect approach would be to bypass the installation of a certified backflow prevention device to appease the client and save them money. This action directly violates plumbing codes and health department regulations designed to prevent the contamination of potable water. Ethically, it represents a dereliction of duty, as the technician is aware of a risk and chooses to ignore it for financial or convenience reasons. Another incorrect approach would be to install a non-certified or makeshift device. While it might appear to address the immediate concern, it fails to meet the stringent performance and testing standards required for certified backflow prevention assemblies, leaving the water supply vulnerable and the technician in violation of regulations. A third incorrect approach would be to simply walk away from the job without adequately informing the client of the risks and regulatory obligations. While this avoids direct complicity, it does not fulfill the professional responsibility to educate and guide the client towards a safe and compliant solution. The professional decision-making process for similar situations involves a clear understanding of the applicable codes and regulations. The technician should first identify the potential cross-connection and assess the associated risks. Next, they must consult the relevant plumbing codes and health department guidelines to determine the required backflow prevention methods. A thorough explanation of these requirements and the associated risks should be presented to the client, emphasizing the legal and public health implications. If the client remains resistant, the technician should document their findings, recommendations, and the client's refusal, and consider advising the client to seek a second opinion or consult with the local water authority. Ultimately, the technician's commitment to public safety and regulatory compliance must be paramount. Question 5. The risk matrix shows that improper drainage and venting can lead to significant health hazards and property damage. A technician is called to a residence experiencing slow drains and occasional foul odors. The technician suspects a blockage in the main drain line. Which approach best optimizes the process while adhering to regulatory requirements for drainage, waste, and vent systems? Option A. Temporarily bypass the main vent stack to improve drainage flow while investigating the blockage, as this can sometimes alleviate pressure. Option B. Focus solely on clearing the visible drain opening, assuming the odor is a minor byproduct of the slow drain and not indicative of a larger system issue. Option C. Conduct a thorough inspection of the entire DWV system, including vent pipes and trap seals, to diagnose the root cause of the slow drainage and odors before attempting any clearing or repair. Option D. Immediately attempt to clear the suspected blockage using high-pressure water jetting, as this is typically the fastest method for resolving drain issues. The correct answer is C. Conduct a thorough inspection of the entire DWV system, including vent pipes and trap seals, to diagnose the root cause of the slow drainage and odors before attempting any clearing or repair. Explanation: this scenario is professionally challenging because it requires a plumbing technician to balance efficiency with strict adherence to safety and regulatory standards when dealing with a potentially hazardous DWV system issue. The risk matrix highlights potential consequences of improper drainage, waste, and vent system maintenance, emphasizing the need for a methodical and compliant approach. The correct approach involves a thorough, step-by-step diagnostic process that prioritizes identifying the root cause of the drainage issue before implementing any repair. This aligns with the fundamental principles of plumbing practice and regulatory requirements, which mandate that repairs address the underlying problem to prevent recurrence and ensure public health and safety. Specifically, regulations governing DWV systems, such as those outlined in the International Plumbing Code (IPC) or Uniform Plumbing Code (UPC), depending on the specific jurisdiction adopted for the Certified Plumbing Technician exam, require proper venting to prevent sewer gas backup and ensure efficient waste removal. A diagnostic approach ensures that any proposed solution, such as clearing a blockage or repairing a vent pipe, is appropriate for the identified problem and does not create new issues or violate code. An incorrect approach that immediately resorts to aggressive clearing methods without diagnosis fails to address the potential underlying cause, which could be a structural issue with the DWV system, a faulty vent, or an improperly sloped drain. This bypasses the critical step of understanding the system's integrity and could lead to further damage or incomplete resolution, violating the principle of performing work that is safe and code compliant. Another incorrect approach that involves bypassing a vent system, even temporarily, is a severe regulatory and ethical failure. Vent systems are integral to DWV function, preventing siphoning of trap seals and allowing for proper drainage. Bypassing a vent can lead to sewer gas entering the building, posing significant health risks and violating numerous plumbing codes designed to protect occupants. Finally, an approach that focuses solely on speed without considering the long-term implications or regulatory compliance risks compromising the integrity of the DWV system and potentially creating future hazards, which is contrary to the professional responsibility of a certified technician. Professionals should employ a decision-making framework that begins with a comprehensive assessment of the problem, referencing relevant codes and manufacturer specifications. This is followed by a systematic diagnostic process to pinpoint the exact cause. Only then should solutions be considered, with a clear evaluation of their compliance with all applicable regulations and their long-term effectiveness. Prioritizing safety, code compliance, and thoroughness over expediency is paramount in DWV system work. Question 6. Operational review demonstrates a homeowner is requesting the installation of a system to reuse water from their washing machine and shower for landscape irrigation. The homeowner refers to this water as reclaimed water and believes it can be directly connected to the irrigation system without special considerations. As a certified plumbing technician, you are aware that the Certified Plumbing Technician exam's regulatory framework defines gray water and has specific requirements for its use. How should you proceed? Option A. Install the system as requested, assuming reclaimed water is a general term and that direct connection for irrigation is permissible without further code review. Option B. Inform the homeowner that reusing any water for irrigation is not permitted by the plumbing code and refuse to perform the work. Option C. Explain to the homeowner that the water from the washing machine and shower is classified as gray water under the code, and therefore, its reuse for irrigation requires a system designed and installed according to specific code provisions to prevent cross-contamination and ensure public health, offering to design and install such a compliant system. Option D. Advise the homeowner that they can connect the washing machine and shower directly to the irrigation system, as long as they use a simple filter, as this is a common practice for water conservation. The correct answer is C. Explain to the homeowner that the water from the washing machine and shower is classified as gray water under the code, and therefore, its reuse for irrigation requires a system designed and installed according to specific code provisions to prevent cross-contamination and ensure public health, offering to design and install such a compliance system. Explanation. This scenario presents a professional challenge because it requires a plumbing technician to interpret and apply specific code definitions in a situation where a client's request might conflict with established safety and health standards. The technician must balance client satisfaction with their ethical and legal obligation to adhere to the certified plumbing technician exam's regulatory framework. Misinterpreting or ignoring code definitions can lead to unsafe installations, potential health hazards, and legal repercussions. The correct approach involves accurately identifying the relevant code definition for gray water and applying it to the proposed system. This means understanding that while gray water can be reused for specific purposes like irrigation, it is distinct from potable water and requires specific design and installation standards to prevent cross-contamination. Adhering to the precise definition ensures the system is designed and installed in a manner that complies with the code, protecting public health and safety. This aligns with the ethical duty of a certified plumbing technician to uphold professional standards and regulatory requirements. An incorrect approach would be to proceed with the installation without a clear understanding of the gray water definition, potentially treating it as potable water or failing to implement the necessary separation and treatment requirements. This failure to adhere to the specific definition of gray water, as outlined in the relevant plumbing code, is a direct violation of the regulatory framework. It risks cross-contamination of potable water supplies, which is a significant public health hazard and a breach of professional responsibility. Another incorrect approach would be to dismiss the client's request outright without exploring compliance solutions. While safety is paramount, a professional technician should be able to explain the code requirements and potentially offer alternative, code-compliant methods for water conservation if the initial proposal is not feasible. Simply refusing without explanation or understanding demonstrates a lack of customer service and potentially a misunderstanding of the code's intent to promote safe and efficient plumbing practices. The professional decision-making process in such situations should involve 1. Thoroughly understanding the client's request. 2. Consulting the specific plumbing code definitions relevant to the request, in this case, gray water and potentially potable water and cross-connection. 3. Evaluating the request against these definitions and associated code requirements for design, installation, and materials. 4. Communicating clearly with the client about code compliance and any limitations or necessary modifications. 5. Proposing code-compliant solutions that meet the client's objectives where possible. Question 7. The efficiency study reveals that a plumbing contractor is consistently completing projects ahead of schedule by omitting the formal permit application process and scheduling inspections only after the majority of the work is finished, often requesting expedited, informal reviews. Which of the following actions best aligns with regulatory compliance and professional responsibility for obtaining permits and undergoing inspections? Option A. Submitting a complete permit application to the local building department prior to commencing any work and scheduling all required inspections at the appropriate stages of construction as mandated by the plumbing code. Option B. Informing the client that permits and inspections are optional for minor renovations and proceeding with the work without formal approval, relying on the contractor's experience to ensure safety. Option C. Proceeding with plumbing installations based on a verbal understanding with a municipal inspector that inspections will be conducted later, and submitting the permit application concurrently with the final inspection request. Option D. Completing all plumbing work without obtaining a permit, and then submitting a request for a final inspection, arguing that the work was completed efficiently and to the contractor's standards. The correct answer is A. Submitting a complete permit application to the local building department prior to commencing any work and scheduling all required inspections at the appropriate stages of construction as mandated by the plumbing code. Explanation. This scenario presents a common challenge in plumbing practice, balancing project timelines with the mandatory regulatory requirements for permitting and inspections. The professional challenge lies in understanding that while clients and contractors may prioritize speed, adherence to the permitting and inspection process is not optional. It is a legal and safety imperative. Failure to comply can lead to significant legal repercussions, safety hazards, and project delays far exceeding any initial time savings. The correct approach involves proactively engaging with the local building department to understand and fulfill all permit application requirements before commencing work, and scheduling inspections at the designated milestones. This ensures that the work is performed in accordance with the adopted plumbing codes, which are designed to protect public health and safety. Regulatory justification stems directly from the building codes and plumbing codes adopted by the jurisdiction, which mandate permits for new installations, alterations, and repairs, and require inspections to verify compliance. Ethically, a plumber has a duty to perform work safely and competently, which includes ensuring it meets all legal standards. An incorrect approach of proceeding without a permit or skipping required inspections is a direct violation of the law. This bypasses the crucial oversight intended to prevent unsafe installations, such as improper venting, inadequate water supply, or faulty drainage, which could lead to health risks, e.g., backflow contamination, gas leaks, or property damage, e.g., water damage, fire hazards. Such actions demonstrate a disregard for public safety and professional responsibility, potentially leading to fines, stop work orders, and liability for any damages or injuries resulting from non-compliant work. Another incorrect approach of assuming a permit is implied, or that a verbal agreement with an inspector is sufficient bypasses the formal, documented process. This leaves no official record of compliance and can lead to disputes and the requirement for work to be redone or inspected retrospectively, often at greater cost and inconvenience. Professionals should employ a decision-making framework that prioritizes regulatory compliance and public safety above all else. This involves thoroughly understanding the permitting and inspection requirements for every project, communicating these requirements clearly to clients and contractors, and building them into project timelines. When faced with pressure to expedite work, the professional must firmly reiterate the legal and safety necessity of the permitting and inspection process, offering solutions that work within the regulatory framework rather than circumventing it. Question 8. Compliance review shows a proposed bathroom renovation includes a sink installation in a commercial establishment. The technician has proposed a standard vanity with a sink that is 36 inches from the floor to the rim. What is the primary consideration for ensuring this plumbing installation meets accessibility code requirements? Option A. Check that the water supply lines are made of durable, corrosion-resistant material. Option B. Verify the sink rim height and ensure adequate knee and toe clearance beneath the sink, as specified by accessibility standards. Option C. Confirm that the faucet is a single lever type for ease of operation. Option D. Ensure the drain pipe is adequately sized to prevent clogs. The correct answer is B. Verify the sink rim height and ensure adequate knee and toe clearance beneath the sink, as specified by accessibility standards. Explanation. This scenario is professionally challenging because it requires the certified plumbing technician to balance code compliance with practical installation realities and client needs, all while adhering to specific accessibility standards. Misinterpreting or overlooking these standards can lead to non-compliant installations, potential safety hazards for users with disabilities, and significant rework, impacting both the technician's reputation and the client's investment. Careful judgment is required to ensure that the plumbing systems not only function correctly, but also meet the stringent requirements of accessibility codes, which are designed to ensure equitable use of facilities. The correct approach involves a thorough understanding and direct application of the relevant accessibility codes, specifically focusing on the requirements for plumbing fixtures and their clearances. This means consulting the applicable building codes and standards, e.g., International Plumbing Code, Americans with Disabilities Act accessibility guidelines, if U.S. jurisdiction is implied by the exam name, to determine precise measurements for sink heights, knee and toe clearances, faucet operation, and grab bar mounting. The technician must verify that the proposed installation meets all specified dimensions and functional requirements for accessibility, ensuring the plumbing system is usable by individuals with a wide range of physical abilities. This direct, code-centric approach is ethically and legally mandated to ensure public safety and non-discrimination. An incorrect approach would be to rely on general plumbing knowledge without specific reference to accessibility codes. While a technician may be skilled in standard plumbing installations, accessibility codes have unique, often non-intuitive, requirements that differ from conventional design. Failing to consult these specific codes means the installation is likely to be non-compliant, potentially creating barriers for users with disabilities. This constitutes a regulatory failure, as it violates the explicit mandates of accessibility legislation and building codes. Another incorrect approach is to assume that a close enough measurement will suffice. Accessibility codes are precise. Deviations, even minor ones, can render a fixture or space unusable for someone with a disability, thereby failing the fundamental purpose of the code. This is a regulatory failure because it disregards the specific, quantifiable requirements set forth in the law. Ethically, it demonstrates a lack of commitment to inclusivity and equal access. A third incorrect approach is to prioritize aesthetics or ease of installation over code requirements. While efficiency and appearance are important, they must never supersede legal mandates for accessibility. Prioritizing these factors without ensuring code compliance leads to a non-compliant installation, which is a regulatory failure and an ethical lapse, as it prioritizes convenience over the rights and needs of individuals with disabilities. The professional reasoning process for similar situations should involve a systematic approach. 1. Identify the specific project requirements, noting any mention of accessibility or universal design. 2. Consult the relevant local, state, and federal codes and standards applicable to the project's jurisdiction, paying particular attention to accessibility chapters or sections. 3. If any ambiguity exists, seek clarification from the relevant code enforcement agency or a qualified accessibility consultant. 4. Plan the installation based on precise measurements and specifications derived directly from the codes. 5. During installation, verify all dimensions and functional aspects against the code requirements. 6. Document all compliance checks and any deviations or justifications, if permitted by code. Question 9. The assessment process reveals a scenario where a plumbing technician is tasked with sizing the water supply piping for a residential bathroom addition. The technician has correctly identified the fixture units for all proposed fixtures. However, when determining the pipe size, the technician is considering 3 different methods: one that strictly uses the total fixture unit count to select a pipe size from a code table, another that arbitrarily selects a larger pipe size than indicated by the fixture units to be safe, and a third that considers the potential for simultaneous fixture use to estimate a realistic peak flow rate, and then sizes the pipe accordingly using code-specified flow rate tables. Which of these approaches best aligns with the principles of responsible and compliant plumbing practice as defined by standard regulatory frameworks for water supply pipe sizing? Option A. Prioritizing the selection of the smallest pipe size that meets the minimum fixture unit requirement to minimize material costs. Option B. Arbitrarily selecting a larger pipe size than indicated by the fixture units to be safe, without specific hydraulic justification. Option C. Considering the potential for simultaneous fixture use to estimate a realistic peak flow rate, and then sizing the pipe accordingly using code-specified flow rate tables. Option D. Strictly using the total fixture unit count to select a pipe size from a code table, without further consideration of flow dynamics. Correct answer is C. Considering the potential for simultaneous fixture use to estimate a realistic peak flow rate, and then sizing the pipe accordingly using code-specified flow rate tables. Explanation: this scenario is professionally challenging because it requires a technician to balance the practical demands of a plumbing system with the regulatory requirements for safe and efficient water supply. Misinterpreting or misapplying pipe sizing guidelines can lead to underperforming fixtures, increased water hammer, potential damage to the system, and non-compliance with building codes, all of which have significant cost and safety implications. Careful judgment is required to ensure the chosen pipe size adequately serves the intended fixtures while adhering to established standards. The correct approach involves understanding the relationship between fixture units and the corresponding flow rates, and then using these values to select the appropriate pipe diameter, according to the prescriptive sizing tables or methods outlined in the relevant plumbing code. This method is correct because it is directly mandated by the governing regulatory framework, which is designed to ensure public health and safety by preventing issues like insufficient water pressure, velocity-related problems, and system failures. Adherence to these code-specified methods is an ethical and legal obligation for a certified plumbing technician. An incorrect approach that relies solely on the number of fixture units without considering the potential peak flow rate is professionally unacceptable. This fails to account for the dynamic nature of water usage, where multiple fixtures might be used simultaneously, leading to a demand that exceeds what a pipe sized only for total fixture units might handle. This violates the spirit and letter of the code, which aims to ensure adequate service under all foreseeable conditions. Another incorrect approach that involves arbitrarily increasing pipe sizes beyond code recommendations without a specific engineering justification or a clear understanding of the system's hydraulic characteristics is also professionally flawed. While seemingly cautious, this can lead to inefficient water delivery, increased material costs, and potentially lower water velocities, which can sometimes contribute to stagnation issues. It deviates from the established, tested, and regulated methods, suggesting a lack of confidence in or understanding of the code's provisions. Finally, an approach that prioritizes minimizing material costs by selecting the smallest possible pipe size that meets the minimum fixture unit requirement, without a thorough assessment of the potential for simultaneous use and the resulting flow rate, is a critical ethical and regulatory failure. This approach directly risks system underperformance and potential code violations, prioritizing short-term cost savings over long-term functionality and safety, which is contrary to the professional responsibilities of a certified plumbing technician. The professional decision-making process for similar situations should involve a systematic review of the project's plumbing plans, identification of all fixtures and their respective fixture unit ratings, and a clear understanding of the applicable plumbing code's requirements for water supply pipe sizing. This includes consulting the code's tables for converting fixture units to flow rates, and then determining the appropriate pipe diameter based on the calculated flow rate and the maximum permissible velocity. If the situation presents unusual circumstances or complex system demands, consulting with a licensed engineer or seeking clarification from the local building department is a prudent step to ensure compliance and optimal system performance. Question 10. Market research demonstrates that a significant portion of plumbing technicians struggle to consistently implement the latest code revisions. A certified plumbing technician, operating within the specified regulatory framework for this exam, is tasked with a complex installation that involves new venting requirements. Which of the following actions best reflects the technician's professional responsibility regarding code updates and revisions? Option A. Rely on general industry best practices for venting, as these are typically sufficient to meet safety standards. Option B. Wait for the project's inspection to identify any discrepancies with the new code requirements. Option C. Proceed with the installation based on the technician's understanding of previous code versions, assuming the new requirements are minor variations. Option D. Proactively consult the official published code book and any supplementary bulletins or addenda issued by the relevant regulatory authority for the most current venting requirements. The correct answer is D. Proactively consult the official published code book and any supplementary bulletins or addenda issued by the relevant regulatory authority for the most current venting requirements. Explanation. Scenario analysis. This scenario presents a common challenge for plumbing technicians: the need to adapt to evolving building codes and standards. The professional challenge lies in ensuring that all work performed is not only functional but also compliant with the latest regulations, which are designed to protect public health, safety, and welfare. Failure to stay current can lead to failed inspections, costly rework, potential liability, and damage to professional reputation. The requirement to adhere strictly to the certified plumbing technician exam's specified regulatory framework, laws, and guidelines means that knowledge must be precise and jurisdiction-specific, without relying on outdated information or general best practices. Correct approach analysis. The correct approach involves actively seeking out and understanding the most recent updates to the plumbing code relevant to the certified plumbing technician exam's jurisdiction. This demonstrates a commitment to professional integrity and regulatory compliance. Specifically, this means consulting official sources such as the governing body's website, official code publications, or attending accredited training sessions that cover code revisions. This proactive engagement ensures that the technician's knowledge base is current, directly aligning with the exam's emphasis on code updates and revisions. Adhering to the specified regulatory framework is paramount, and this approach directly addresses that requirement by prioritizing official, jurisdiction-specific information. Incorrect approaches analysis. Relying solely on past experience or assuming that previous code versions are still valid is a significant regulatory failure. Codes are updated for reasons of safety and technological advancement, and ignoring these changes can lead to non-compliant installations. This approach fails to meet the core requirement of staying current with code changes and updates as mandated by the exam scope. Assuming that general plumbing best practices are equivalent to specific code requirements is another failure. While best practices are valuable, they do not supersede legally mandated codes. Codes are the minimum standard of safety and performance, and deviating from them, even with seemingly good intentions, is a violation of regulatory compliance. This approach neglects the specific, legally binding nature of the codes the exam is based upon. Waiting for a failed inspection to discover code changes is a reactive and unprofessional approach. It indicates a lack of proactive engagement with regulatory updates and can result in significant financial and time costs for both the technician and the client. This approach demonstrates a failure to meet the ongoing professional responsibility of staying current with code changes and updates, which is a critical component of the Certified Plumbing Technician exam. Professional reasoning. Professionals in regulated trades must adopt a proactive and continuous learning mindset. The decision-making process should prioritize the acquisition and application of up-to-date regulatory knowledge. This involves 1. Identifying the relevant regulatory body and its official communication channels for code updates. 2. Regularly consulting these sources for any revisions or new additions of the plumbing code. 3. Participating in continuing education or training specifically focused on code changes. 4. Verifying that all work performed strictly adheres to the latest adopted code, ensuring compliance and safeguarding public interest. Question 11. Governance review demonstrates that a client has requested the installation of a specific brand and model of water filtration system to be integrated with their existing water softener. The client has provided a link to the filtration system and stated, "I've heard this one is good, and I want this exact one installed, even if it's not the one you usually recommend." The technician has not previously worked with this specific filtration system and is unsure if it is compatible with the existing water softener or if it meets all local plumbing code requirements for residential installations. What is the most appropriate course of action for the certified plumbing technician? Option A. Research the specified filtration system's technical specifications, compatibility with the existing water softener, and verify its compliance with all applicable local plumbing codes and manufacturer installation guidelines before proceeding with any installation. Option B. Install the requested filtration system immediately, assuming it will function correctly as the client has expressed a strong preference for it. Option C. Advise the client that only specific, pre-approved filtration systems can be installed and recommend one of those, regardless of the client's request. Option D. Proceed with the installation of the requested filtration system, but inform the client that the warranty may be voided due to the non-standard choice. The correct answer is A. Research the specified filtration system's technical specifications, compatibility with the existing water softener, and verify its compliance with all applicable local plumbing codes and manufacturer installation guidelines before proceeding with any installation. Explanation. Scenario analysis. This scenario is professionally challenging because it requires a plumbing technician to balance client requests with regulatory compliance and product warranty requirements. The client's desire for a specific, potentially non-compliant filtration system introduces a conflict between customer satisfaction and adherence to established standards and manufacturer guidelines. A hasty decision could lead to system failure, voided warranties, or even legal repercussions if the installation violates local plumbing codes. Careful judgment is required to identify the safest, most effective, and compliant solution. Correct approach analysis. The correct approach involves thoroughly researching the specified filtration system's compatibility with the existing water softener and verifying its compliance with all applicable local plumbing codes and manufacturer installation guidelines. This ensures the system is installed safely, functions as intended, and maintains its warranty. Adherence to these standards is paramount for professional integrity and to protect both the client and the technician from potential liabilities. This approach prioritizes due diligence and regulatory adherence over immediate client preference when that preference may compromise safety or compliance. Incorrect approach is analysis. Installing the filtration system without verifying its compatibility with the water softener or its compliance with local codes is a significant regulatory and ethical failure. This bypasses essential safety checks and could lead to improper system operation, damage to the softener, or a violation of plumbing regulations, potentially resulting in fines or requiring costly remediation. Recommending a different filtration system solely based on the client's stated budget without assessing its technical suitability or compliance is also problematic. While cost is a factor, prioritizing it over technical requirements and regulatory mandates can lead to a system that is ineffective, short-lived, or non-compliant, ultimately failing to meet the client's underlying need for clean, safe water and potentially voiding warranties. Proceeding with the installation based on the client's assurance that it will work without independent verification is a dereliction of professional duty. The technician is responsible for ensuring the installation meets all technical and regulatory standards, not relying on unsubstantiated claims. This approach exposes the client and the technician to risks associated with improper installation and potential system failure. Professional reasoning. Professionals should employ a decision-making framework that prioritizes safety, compliance, and efficacy. This involves 1. Understanding the client's needs and constraints. 2. Identifying all relevant regulations, codes, and manufacturer specifications. 3. Evaluating available products and solutions against these requirements. 4. Communicating potential risks and compliant alternatives clearly to the client. 5. Documenting all decisions and justifications. In this case, the technician must first confirm the technical compatibility and regulatory compliance of the requested system before proceeding, offering compliant alternatives if the requested system is unsuitable. Question 12. Cost-benefit analysis shows that a client desires a high-performance showerhead that significantly exceeds typical flow rates, but the existing water supply pressure and flow rate in the building are at the upper limit of what is considered safe and efficient according to the Certified Plumbing Technician exam's regulatory framework. Which approach best balances client satisfaction with regulatory compliance? Option A. Inform the client that the showerhead is compatible with their system, without mentioning potential pressure or flow limitations or code implications, to avoid discouraging the purchase. Option B. Advise the client that the desired showerhead cannot be installed due to existing system limitations and potential code violations, and propose alternative, code-compliant fixtures that can be supported by the current water supply. Option C. Install the high-performance showerhead, informing the client that it may operate at a reduced performance level due to existing system limitations and potential code restrictions. Option D. Install the high-performance showerhead immediately to satisfy the client's request and address any potential pressure or flow issues that arise after installation. The correct answer is C. Install the high-performance showerhead, informing the client that it may operate at a reduced performance level due to existing system limitations and potential code restrictions. Explanation. This scenario is professionally challenging because it requires a plumbing technician to balance client expectations, regulatory compliance, and the practical realities of water systems. The client's desire for a specific aesthetic outcome, e.g., a high-flow showerhead, must be reconciled with the existing infrastructure's capacity and the governing plumbing codes, which prioritize safety and functionality over individual preferences when those preferences could compromise the system. Careful judgment is required to identify potential conflicts between desires and regulations before installation. The correct approach involves prioritizing adherence to the Certified Plumbing Technician exam's regulatory framework, specifically concerning water pressure and flow rate limitations. This means assessing the existing water supply pressure and flow rate against the requirements of the proposed fixtures and the maximum allowable pressures/flow rates stipulated by relevant codes. If the existing supply cannot adequately or safely support the desired fixture without exceeding code limits or causing system strain, the technician must inform the client of these limitations and propose compliant alternatives or necessary system upgrades. This approach is justified by the regulatory requirement to design and install systems that are safe, functional, and comply with established standards, preventing potential damage, water waste, or hazards. An incorrect approach would be to install the high-flow fixture without verifying the existing water pressure and flow rate against code requirements. This failure to assess system capacity and regulatory compliance could lead to overpressurization, damage to the fixture or other plumbing components, excessive water consumption, and potential violation of local plumbing codes. Another incorrect approach is to simply inform the client that the fixture is high flow without explaining the implications for their existing system or the relevant code restrictions. This misrepresents the situation and fails to provide the client with the necessary information to make an informed decision within regulatory boundaries. Installing the fixture and then addressing any issues that arise would be a reactive and unprofessional approach, demonstrating a lack of foresight and adherence to preventative code compliance. Professionals should employ a decision-making framework that begins with understanding the client's request, followed by a thorough assessment of the existing system's capabilities and limitations. This assessment must then be cross-referenced with the specific requirements and restrictions outlined in the Certified Plumbing Technician exam's regulatory framework regarding water pressure and flow rates. If a discrepancy or potential conflict is identified, the professional must clearly communicate the regulatory constraints and potential system impacts to the client, offering compliant solutions and explaining the rationale behind these recommendations. This proactive, code-centric, and client-informed approach ensures both regulatory adherence and client satisfaction. Question 13. Process analysis reveals a homeowner reporting a persistent metallic taste and odor in their well water, along with occasional sediment. The well system is approximately 15 years old and includes a submersible pump, a pressure tank, and a basic sediment filter. The homeowner is eager for a quick fix and suggests replacing the pressure tank, believing it to be the source of the metallic taste. As a certified plumbing technician operating under the regulations of specified jurisdiction, e.g., California Plumbing Code, Uniform Plumbing Code, UPC, as adopted by the state, what is the most appropriate course of action? Option A. Advise the homeowner that well system issues are outside the scope of a plumbing technician's expertise and recommend they contact a well drilling company for an assessment. Option B. Immediately replace the pressure tank as suggested by the homeowner, as metallic tastes can sometimes be associated with aging tank components. Option C. Install a more advanced multi-stage water filtration system, including activated carbon and ion exchange filters, to address the metallic taste and odor without further investigation into the well's integrity. Option D. Conduct a thorough inspection of the wellhead, casing, and pump for signs of corrosion or damage. Perform water quality testing to identify specific contaminants, and consult relevant state and local codes for well construction and maintenance standards before recommending any repairs or replacements. The correct answer is D. Conduct a thorough inspection of the wellhead, casing, and pump for signs of corrosion or damage. Perform water quality testing to identify specific contaminants, and consult relevant state and local codes for well construction and maintenance standards before recommending any repairs or replacements. Explanation. This scenario is professionally challenging because it involves a critical component of a private water supply, the well system, where improper installation or maintenance can lead to significant health risks and costly repairs. The certified plumbing technician must balance the client's desire for a quick solution with the absolute necessity of adhering to established codes and best practices for public health and safety. The challenge lies in identifying the root cause of the water quality issue and implementing a solution that is not only effective, but also compliant with all relevant regulations. The correct approach involves a systematic diagnostic process that begins with understanding the reported problem and then moves to a thorough inspection of the entire well system, including the wellhead, casing, pump, pressure tank, and any treatment systems. This methodical approach ensures that all potential sources of contamination or malfunction are considered. Specifically, it requires consulting the relevant state or local plumbing codes and well construction standards to determine the appropriate materials, installation methods, and maintenance schedules. The regulatory justification stems from the mandate to protect public health by ensuring safe drinking water. This includes adherence to standards for well sealing, backflow prevention, and water quality testing protocols. Ethical considerations also demand that the technician provide a safe and reliable water supply, which necessitates a comprehensive and compliant solution. An incorrect approach that focuses solely on replacing the pressure tank without a thorough investigation of the well itself fails to address the potential root cause of the water quality issue. This could be contamination entering the well from surface runoff due to an improperly sealed wellhead or casing, or a failing submersible pump. Such an approach is a regulatory failure because it bypasses the required diagnostic steps and could leave the underlying problem unaddressed, potentially leading to continued or worsening water contamination, which violates public health mandates. Another incorrect approach, which involves recommending a complex, expensive water treatment system without first confirming the source and nature of the contamination, is also a regulatory and ethical failure. While treatment systems can be necessary, they are often a secondary solution. Installing an elaborate system when the primary issue is a faulty well seal or a contaminated aquifer is a misallocation of resources and does not solve the fundamental problem. It also fails to comply with regulations that often require addressing the source of contamination before implementing treatment. A third incorrect approach, which involves relying on anecdotal evidence or past experiences with similar-sounding problems without consulting current codes or performing necessary tests, is a significant professional and regulatory failure. Plumbing codes are updated to reflect new knowledge and best practices. Ignoring these, or failing to conduct proper water quality testing and system diagnostics, means the technician is not operating within the established safety and performance standards, potentially jeopardizing the client's health and exposing the technician to liability. The professional decision-making process for similar situations should involve a clear, step-by-step diagnostic protocol. This begins with active listening to the client's concerns, followed by a comprehensive visual inspection of the entire well system. Crucially, this must be coupled with a review of relevant local and state plumbing codes, well construction standards, and any applicable health department guidelines. Water quality testing should be performed to identify specific contaminants. Based on these findings, the technician can then propose a solution that is both compliant with regulations and effectively addresses the identified problem, prioritizing source control and system integrity over superficial fixes. Question 14. Benchmark analysis indicates that a homeowner is requesting a plumbing modification in their kitchen sink drain that involves removing the existing P-trap and installing a direct drain connection to the sewer line, citing aesthetic concerns and a desire for unimpeded water flow. The homeowner also expresses a strong preference against having any visible cleanout access point near the drain. As a certified plumbing technician, what is the most ethically and regulatorily sound approach to this request, considering the primary objective of preventing sewer gas intrusion and ensuring maintainability? Option A. Proceed with the direct drain connection as requested by the homeowner, as their satisfaction is the primary goal and they are the paying client. Option B. Install a P-trap that is not designed for kitchen sink applications but is aesthetically pleasing, and advise the homeowner that a cleanout is not strictly necessary for this type of fixture. Option C. Install a P-trap but omit the cleanout, assuring the homeowner that it will still prevent sewer gases and that blockages are unlikely. Option D. Refuse the request outright, explaining that the installation of a P-trap with an accessible cleanout is a mandatory code requirement for preventing sewer gas entry and ensuring proper maintenance, and offer to install a code-compliant P-trap with a discreetly located cleanout if possible. The correct answer is D. Refuse the request outright, explaining that the installation of a P-trap with an accessible cleanout is a mandatory code requirement for preventing sewer gas entry and ensuring proper maintenance, and offer to install a code-compliant P-trap with a discreetly located cleanout if possible. Explanation. This scenario presents a professional challenge because it requires a plumbing technician to balance immediate client demands with long-term public health and safety obligations, as mandated by regulatory frameworks. The technician must exercise sound judgment to ensure that any proposed solution adheres strictly to established codes and standards, even when faced with pressure to deviate. The correct approach involves prioritizing the installation of a properly functioning P-trap with an accessible cleanout, as per the applicable plumbing code. This is the right course of action because it directly addresses the core function of a trap in preventing sewer gases from entering the building and the cleanout's role in facilitating maintenance and preventing blockages. Adherence to the Uniform Plumbing Code, UPC, or the International Plumbing Code, IPC, depending on the specific jurisdiction's adoption, is paramount. These codes specify the requirements for trap types, venting, and cleanout accessibility to ensure sanitary conditions and prevent health hazards. Ethically, a technician has a duty to protect the public's health and safety, which supersedes a client's desire for a less code-compliant or more aesthetically pleasing but functionally inferior solution. An incorrect approach would be to bypass the installation of a P-trap altogether, relying solely on a simple drain connection. This fails to meet the fundamental requirement of a trap to create a water seal, allowing sewer gases to escape into the living space, posing a significant health risk and violating plumbing codes. Another incorrect approach would be to install a P-trap, but omit the cleanout. While the trap itself provides a basic function, the absence of a cleanout severely hinders future maintenance, making it difficult to clear blockages and increasing the likelihood of recurring issues and potential overflow, which is also a violation of code requirements for accessibility and maintainability. Finally, installing a trap that is not designed for the specific application or is improperly sized would also be an incorrect approach, as it would compromise the trap's ability to hold a water seal and function effectively, leading to potential code violations and sanitary issues. Professionals should employ a decision-making framework that begins with identifying the core problem and the applicable regulations. They should then evaluate potential solutions against these regulations, considering both immediate functionality and long-term implications for health, safety, and maintainability. When faced with client preferences that conflict with code requirements, the professional's duty is to educate the client on the code mandates and the reasons behind them, offering compliant solutions. If a client insists on a non-compliant method, the professional must refuse to perform the work and explain that their professional and legal obligations require adherence to the established standards. Question 15. Quality control measures reveal that a plumbing contractor has installed sections of potable water piping using a material that is no longer listed as approved by the current adopted plumbing code for the jurisdiction, although it was permitted under older codes. The client is pressuring the contractor to avoid the cost and delay of replacing the piping, suggesting alternative methods to ensure its safety. What is the most appropriate course of action for the certified plumbing technician to take in this situation? Option A. Complete the installation as planned, without informing the client or the relevant building department, assuming the noncompliance will not be discovered during future inspections. Option B. Argue to the client and the inspector that the piping was acceptable under previous code versions and should be grandfathered in for this project. Option C. Attempt to seal or coat the non-compliant piping to prevent any potential issues and proceed with the installation, assuring the client it will be safe. Option D. Immediately halt the installation and inform the client that the non-compliant piping must be replaced with materials that meet current plumbing code requirements, and then proceed with the replacement after client approval. The correct answer is D. Immediately halt the installation and inform the client that the non-compliant piping must be replaced with materials that meet current plumbing code requirements, and then proceed with the replacement after client approval. Explanation. Scenario analysis. This scenario is professionally challenging because it involves a potential conflict between immediate cost-saving measures and long-term public health and safety, which are paramount in plumbing. The technician must balance the client's desire for a quick fix with the absolute necessity of adhering to established plumbing codes and standards designed to prevent waterborne illnesses and ensure system integrity. Failure to do so can result in significant legal liability, reputational damage, and most importantly, harm to the end users of the water supply. Correct approach analysis. The correct approach involves immediately identifying the non-compliant materials and initiating the process for their replacement with materials that meet current plumbing codes and standards. This is the only professionally responsible action because it directly addresses the identified risk to public health and safety. Plumbing codes, such as those adopted and enforced by the relevant U.S. state or local authority, e.g., International Plumbing Code or Uniform Plumbing Code as adopted by the jurisdiction, mandate the use of approved materials for potable water systems. These codes are legally binding and are designed to prevent contamination and ensure the safe delivery of water. Ethically, a certified plumbing technician has a duty to protect the public's health and welfare, which supersedes any client's desire to cut corners. Incorrect approaches analysis. One incorrect approach involves attempting to disguise or seal the non-compliant materials to avoid immediate replacement. This is a direct violation of plumbing codes, which typically prohibit the use of unapproved materials in potable water systems, regardless of attempts to mitigate their perceived flaws. Such a measure would not guarantee the long-term safety or integrity of the system and could lead to future failures, contamination, and health risks, constituting a significant ethical breach and potential legal liability. Another incorrect approach is to proceed with the installation without informing the client or the relevant building authority about the non-compliant materials, assuming they will not be discovered. This is a serious ethical and professional failing. It involves deception and a deliberate disregard for regulatory oversight. Plumbing inspections are a critical part of the code enforcement process, and intentionally circumventing them is illegal and unethical. It also places the technician in a position of liability if the issue is discovered later. A third incorrect approach is to argue that the materials were acceptable at the time of a previous installation or inspection, even if they are no longer compliant with current codes. While historical context might be relevant in some situations, plumbing codes are updated to reflect advancements in material science and public health understanding. Current code compliance is mandatory for new installations or significant repairs. Relying on outdated standards for new installation or repair is a failure to meet the present-day requirements for safe and effective plumbing, thus violating the spirit and letter of the law. Professional reasoning. When faced with a situation where non-compliant materials are discovered, a certified plumbing technician must follow a structured decision-making process. First, identify the specific code violation and the potential risks associated with the non-compliant material. Second, consult the relevant plumbing codes and standards applicable to the jurisdiction. Third, communicate the findings clearly and professionally to the client, explaining the risks and the mandatory requirements for replacement. Fourth, propose a compliant solution, outlining the necessary steps and materials. Fifth, ensure all work is performed in accordance with the applicable codes and is subject to required inspections. This systematic approach ensures both legal compliance and ethical responsibility. Question 16. The efficiency study reveals that a proposed drainage system for a new multi-unit residential building appears to have a simpler pipe layout than initially designed. When considering pipe sizing for this revised layout, which of the following approaches best ensures compliance with regulatory requirements for effective wastewater conveyance and public health protection? Option A. Increasing the slope of all drainage pipes significantly beyond the code-specified maximum to ensure rapid wastewater flow. Option B. Reducing the size of the drainage pipes to minimize material costs, assuming the simplified layout will compensate for any slight undersizing. Option C. Relying on a visual assessment of the drainage path to ensure water appears to flow downhill, without consulting specific fixture unit calculations or slope requirements. Option D. Calculating the total fixture units for all connected plumbing fixtures, and then using the appropriate code tables to determine the minimum required pipe size for the determined slope. The correct answer is D. Calculating the total fixture units for all connected plumbing fixtures, and then using the appropriate code tables to determine the minimum required pipe size for the determined slope. Explanation. This scenario is professionally challenging because it requires a plumber to balance the theoretical requirements of drainage system design with practical on-site conditions and potential cost implications, all while strictly adhering to regulatory standards. Misinterpreting or deviating from these standards can lead to system failures, health hazards, and legal repercussions. Careful judgment is required to ensure the system is not only compliant, but also functional and durable. The correct approach involves a thorough understanding and application of the established fixture unit method and slope requirements as mandated by the relevant plumbing codes. This method ensures that the drainage system is adequately sized to handle the expected wastewater flow from all connected fixtures, preventing backups and promoting proper sanitation. Adhering to the specified slopes is critical for gravity flow, ensuring waste and water move efficiently to the main sewer line without accumulating solids that could cause blockages. This approach is ethically and regulatorily justified because it directly fulfills the primary objective of plumbing codes, protecting public health and safety by ensuring the proper functioning of sanitary drainage systems. An incorrect approach that prioritizes minimizing pipe material cost by undersizing the drainage pipes, even if it appears to meet a superficial interpretation of fixture unit counts, is regulatorily flawed. Plumbing codes provide specific tables and methodologies for calculating fixture units and corresponding pipe sizes to account for peak flow rates and the potential for solids transport. Undersizing ignores these critical factors, leading to a system that is likely to fail under normal operating conditions, violating the code's intent and potentially creating a public health nuisance. Another incorrect approach that involves arbitrarily increasing the slope beyond the code-specified maximums to ensure faster drainage is also problematic. A steeper slope can increase flow velocity. Exceeding the maximum can lead to scouring of the pipe interior, insufficient flushing of solids, and potential damage to pipe joints. Codes specify a range of acceptable slopes for a reason, balancing flow rate with the need for proper waste transport and pipe longevity. Deviating from this range without explicit code allowance is a regulatory failure. A third incorrect approach that relies solely on the visual appearance of the drainage path without consulting the fixture unit tables and slope requirements is fundamentally unsound. Visual assessment is subjective and cannot accurately quantify the drainage load or ensure compliance with the precise requirements of the code. This approach bypasses the established, scientifically based methodology designed to prevent system failures and protect public health, representing a significant regulatory and ethical lapse. A professional decision-making process for similar situations should involve a systematic review of the project plans against the applicable plumbing code. This includes identifying all fixtures and their respective fixture unit values, calculating the total fixture units for each section of the drainage system, determining the required pipe size based on the code's sizing tables for the calculated fixture units and the chosen slope, and verifying that the installed slope falls within the code-specified range. When in doubt, consulting the code's commentary or seeking clarification from the local building department is essential. Question 17. The evaluation methodology shows a single-story residential dwelling with several plumbing fixtures located along an exterior wall. The plumbing layout makes the installation of a single, central vent stack for all fixtures impractical due to the distance and configuration. Which type of venting system is most appropriate to ensure proper drainage and prevent sewer gas intrusion for all fixtures in this dwelling? Adhering to standard plumbing code principles. Option A, a single stack vent extending from the highest fixture. Option B, individual vents or branch vents for each fixture or group of fixtures connecting to the atmosphere. Option C, no venting system as the fixtures are on an exterior wall. Option D, a vent stack serving the entire plumbing system. The correct answer is B, individual vents or branch vents for each fixture or group of fixtures connecting to the atmosphere. Explanation. This scenario is professionally challenging because it requires a technician to apply specific knowledge of venting system types and their functions within the context of a real-world installation, ensuring compliance with established plumbing codes. The technician must not only identify the correct vent type, but also understand its purpose in maintaining proper fixture drainage and preventing sewer gas intrusion. Careful judgment is required to select the vent that best serves the specific plumbing configuration while adhering to regulatory requirements. The correct approach involves recognizing that a single-story dwelling with multiple fixtures on an exterior wall, where a central vent stack would be impractical or overly complex, necessitates an individual vent for each fixture or a group of fixtures. This individual vent, or a branch vent serving a group, connects to the atmosphere and allows air to enter the drainage system, preventing siphoning of fixture traps and ensuring proper airflow for drainage. This aligns with the fundamental principles of venting systems as outlined in plumbing codes, which aim to protect public health by preventing sewer gas release and ensuring efficient fixture operation. An incorrect approach would be to assume that a single stack vent is sufficient for all fixtures in this configuration. A stack vent is typically the extension of a soil or waste stack above the highest horizontal branch, serving as a vent for that stack. In this scenario, relying solely on a stack vent might not adequately serve fixtures located further from the stack or on different sides of the building, potentially leading to siphoning issues. Another incorrect approach would be to propose a vent stack without a clear understanding of its specific function, which is primarily to provide a separate vent connection for a group of fixtures or a soil/waste stack, often used in multi-story buildings. Without proper application to the specific layout, it fails to address the venting needs of all fixtures. Finally, proposing no vent at all is a critical failure, directly violating plumbing codes and creating significant health and safety hazards due to potential sewer gas backflow and fixture trap siphoning. Professional decision-making in such situations requires a systematic approach. First, thoroughly understanding the plumbing layout and fixture locations. Second, recalling the definitions and functions of various vent types: individual, branch, circuit, vent stack, stack vent. Third, consulting the applicable plumbing code to determine the specific requirements for the given installation. And fourth, selecting the vent type that meets code requirements and effectively serves the intended purpose of maintaining trap seals and allowing proper drainage. Question 18. Risk assessment procedures indicate that a new building requires a connection to the municipal sewer system. Which of the following methods best ensures compliance with regulatory frameworks and protects public health and the environment during this connection process? Option A. Excavate to the municipal sewer main and install a direct tap using a threaded adapter, assuming the existing sewer has sufficient capacity and flow. Option B. Excavate to the municipal sewer main, install a standard T-fitting at the nearest accessible point, and backfill immediately after connecting the building drain. Option C. Obtain the necessary permits, verify the invert elevation of the municipal sewer main, use an approved connection fitting e.g. a Y or saddle specifically designed for the sewer main material, ensure proper pipe bedding and slope, and schedule required inspections with the local authority. Option D. Connect the building drain to the municipal sewer main at any convenient depth, using whatever pipe material is readily available on site, and bypass any required permitting or inspections to expedite the project. Correct answer is B. Excavate to the municipal sewer main, install a standard T-fitting at the nearest accessible point, and backfill immediately after connecting the building drain. Explanation. This scenario is professionally challenging because improper sewer connections can lead to significant environmental contamination, public health risks, and costly remediation. A certified plumbing technician must exercise meticulous judgment to ensure compliance with all applicable regulations and best practices for public safety and environmental protection. The correct approach involves a thorough understanding and application of local municipal sewer connection ordinances and state plumbing codes. This includes verifying the invert elevation of the existing municipal sewer, ensuring proper pipe material and bedding, and utilizing approved connection methods such as Ys or saddles, specifically designed for the type of sewer main. It also necessitates obtaining the required permits and scheduling inspections with the local building department or public works agency before backfilling. This methodical process guarantees that the connection is structurally sound, watertight, and integrates seamlessly with the municipal system without causing blockages or surcharging, thereby adhering to regulatory requirements designed to protect public health and the environment. An incorrect approach of simply tapping into the sewer main with a standard T-fitting without verifying invert elevations or using approved fittings is a critical regulatory failure. Municipal codes typically mandate specific connection types and elevations to prevent backflow and ensure adequate drainage. Failing to obtain permits and schedule inspections is also a direct violation of building codes and can result in fines, mandatory rework, and legal liability. Another incorrect approach of using unapproved materials or improper bedding for the connection pipe compromises the integrity of the system, risking leaks and structural failure, which contravenes plumbing codes designed for durability and safety. Lastly, assuming the invert elevation of the municipal sewer without verification can lead to improper slope, causing sewage backup and potential environmental discharge, a direct violation of environmental protection regulations. Professional reasoning in such situations requires a systematic approach. First, identify and obtain all relevant local and state regulations pertaining to sewer connections. Second, conduct a site-specific assessment, including verifying existing sewer main details. Third, select materials and methods that are explicitly approved by code and the municipality. Fourth, secure all necessary permits and schedule all required inspections. Finally, document all work performed and communications with authorities. This structured decision-making process ensures that all regulatory and ethical obligations are met, safeguarding both the public and the technician's professional standing. Question 19. The performance metrics show a significant increase in water bills for a commercial property, prompting the owner to request a review of their plumbing system for potential cost reductions. As a certified plumbing technician, what is the most appropriate course of action to address the client's concerns while ensuring compliance with water conservation codes? Option A. Suggest upgrading to high-pressure fixtures to improve performance, without specifically verifying their water consumption rates against conservation codes. Option B. Recommend immediate replacement of all visible plumbing fixtures with the least expensive models available to reduce upfront costs, assuming this will automatically lead to water savings. Option C. Conduct a comprehensive audit of the existing plumbing system, identify specific areas of high water consumption, and propose the installation of WaterSense certified fixtures and low-flow devices that meet or exceed current plumbing code requirements for water efficiency. Option D. Focus solely on repairing any identified leaks and advise the client that further water-saving measures are optional and not mandated by current regulations. The correct answer is C. Conduct a comprehensive audit of the existing plumbing system, identify specific areas of high water consumption, and propose the installation of WaterSense certified fixtures and low-flow devices that meet or exceed current plumbing code requirements for water efficiency. Explanation. Scenario analysis. This scenario presents a professional challenge because it requires a plumbing technician to balance client cost expectations with regulatory compliance and the long-term benefits of water conservation. The technician must assess the current plumbing system's efficiency, identify areas for improvement, and propose solutions that meet both the client's budget and the stringent requirements of water conservation codes. Misinterpreting or neglecting these codes can lead to significant legal penalties, reputational damage, and a failure to protect a vital resource. The challenge lies in effectively communicating the value of water-saving measures, which may have a higher upfront cost, to a client focused on immediate savings. Correct approach analysis. The correct approach involves a thorough assessment of the existing plumbing system to identify specific areas where water usage can be reduced, followed by the proposal of compliant water-saving fixtures and practices. This aligns directly with the certified plumbing technician exam's focus on understanding and implementing water-saving practices as mandated by relevant codes. Specifically, this approach would involve referencing and adhering to the Uniform Plumbing Code, UPC, or the International Plumbing Code, IPC, depending on the jurisdiction's adoption, which sets standards for water efficiency in plumbing fixtures and appliances. For example, the code might specify maximum flow rates for faucets, shower heads, and toilets. Implementing these measures not only ensures compliance, but also provides the client with long-term cost savings through reduced water bills and contributes to environmental sustainability, fulfilling the ethical responsibility of a professional plumber. Incorrect approaches analysis. One incorrect approach is to simply replace fixtures with the cheapest available options without verifying their water efficiency ratings or compliance with current codes. This fails to address the core requirement of water conservation and may result in the installation of non-compliant fixtures, leading to potential fines and the need for costly rework. Another incorrect approach is to assume that all existing fixtures are adequately water efficient and to focus solely on leak detection without exploring proactive water-saving upgrades. While leak detection is important, it does not fulfill the mandate of implementing water-saving practices beyond basic maintenance. A third incorrect approach is to prioritize the client's immediate budget concerns over regulatory requirements by recommending fixtures that do not meet the minimum water efficiency standards, even if they are less expensive. This directly violates the technician's professional obligation to uphold plumbing codes and can expose both the technician and the client to legal repercussions. Professional reasoning. Professionals should approach such situations by first understanding the specific water conservation codes applicable to their jurisdiction. This involves consulting the relevant plumbing codes, e.g., UPC, IPC, and any local amendments. Next, a comprehensive assessment of the client's current system should be conducted, identifying both inefficiencies and opportunities for improvement. The technician should then research and recommend fixtures and technologies that meet or exceed the code's water efficiency requirements. Transparent communication with the client is crucial, explaining the benefits of water-saving measures, including long-term cost savings and environmental impact, alongside any upfront cost differences. Documenting the assessment, recommendations, and the rationale behind them, including code references, is essential for professional accountability and client clarity. Question 20. What factors determine the applicability and enforcement of the International Plumbing Code, IPC, in a specific construction project, considering its scope, intent, and administration? Option A. The subjective interpretation of plumbing best practices by individual tradespeople, independent of formal code provisions. Option B. The personal experience of the plumbing contractor and the perceived efficiency of the proposed installation methods. Option C. The cost-effectiveness of materials and labor and the speed at which the plumbing system can be installed. Option D. The explicit statement of the IPC's scope and intent, coupled with the established administrative procedures for permits and inspections within the governing jurisdiction. The correct answer is D. The explicit statement of the IPC's scope and intent, coupled with the established administrative procedures for permits and inspections within the governing jurisdiction. Explanation. This scenario presents a professional challenge because plumbing technicians must navigate the inherent complexities of the International Plumbing Code (IPC) to ensure public health and safety. The scope, intent, and administration sections of the IPC are foundational, dictating the boundaries of its application, the underlying principles it seeks to uphold, and the mechanisms for its enforcement. A technician's ability to correctly interpret and apply these initial sections directly impacts the legality, safety, and efficacy of their work. Misinterpreting these core elements can lead to non-compliant installations, potential hazards, and significant legal repercussions. The correct approach involves a thorough understanding of the IPC's stated scope and intent as outlined in Chapter 1, Section 101. This includes recognizing that the IPC applies to the installation, alteration, and repair of plumbing systems, and its primary intent is to safeguard public health, safety, and welfare. Furthermore, understanding the administrative provisions, such as those related to the building official's authority and the permit process, is crucial for ensuring compliance. This approach is correct because it directly aligns with the explicit directives and purpose of the IPC, ensuring that all plumbing work is performed within the legal and safety framework established by the code. Adherence to these foundational principles is a regulatory requirement and an ethical imperative for any certified plumbing technician. An incorrect approach would be to focus solely on the technical aspects of plumbing, without considering the code's overarching intent. For instance, prioritizing speed or cost-effectiveness over code compliance, even if the technical execution appears sound, fails to uphold the IPC's intent of public health and safety. This is a regulatory failure because it disregards the code's purpose, and an ethical failure because it potentially compromises the well-being of building occupants. Another incorrect approach is to assume that local amendments or interpretations supersede the IPC's fundamental scope and intent without proper verification. While local jurisdictions can amend the IPC, these amendments must still be consistent with the code's core principles and are typically documented and made available. Ignoring the IPC's foundational scope and intent in favor of unverified local practices is a regulatory failure, as it bypasses the established legal framework for plumbing installations. A third incorrect approach is to neglect the administrative provisions of the IPC, such as the requirement for permits and inspections. This oversight can lead to work being performed without proper oversight, increasing the risk of non-compliance and potential safety issues. This is a significant regulatory failure, as the administrative sections are integral to the code's enforcement and the assurance of compliant installations. The professional reasoning process for similar situations should begin with a comprehensive review of the relevant sections of the IPC, particularly Chapter 1, focusing on scope, intent, and administration. This should be followed by an assessment of any local amendments or jurisdictional requirements, ensuring they are properly documented and understood. When in doubt, consulting with the local building official or a qualified code professional is essential to ensure accurate interpretation and application of the code, thereby upholding both regulatory compliance and professional responsibility.